In this video, we are going to work on the state machine. So click on the script next to state machine to open it in the script editor. I'm going to expand the view, Ctrl-Shift F11 to focus on that for now. So our state machine is going to take our states and it's going to delegate callbacks from Godot to one of them at a time. The first thing we're going to do is get some state that the state machine will delegate the calls to. So let's create a new onReady variable called state. It's going to be of type state, so we get auto-completion. And now we have to find a way to get that node. Which state should we use? Well, one way to do it is to use getChild, the function from the node class that allows us to get a child by index, and we get the first child. The thing is, maybe when you design your state machine, you're going to have many states and you would like to use another one than the first child. Oh, another reason to do that is because when you have parent nodes, we might want to use the child node instead to set the state. So the idle run and not the parent move state. So another way we can do this is by using a node path. So we are going to create a new exported variable called initial state, and it's going to use the type node path. A node path is a precompiled path to a given node. The point here is that we can set it by selecting the state machine in the inspector, and we can select any node that we want to use as our first node. Let's select the state machine and assign the run state, in this case, to it. And so going back to the script, the state is going to be getNode, and we can use initial state here. So you can use a node path along with the getNode function to get the node that corresponds to that path. We're going to do something straight away. It's add an extra variable that we will use for debugging purposes. So we're going to create a new variable, onReady variable state name, or maybe we can do it variable state name. It's going to be a string. And so that state name we're going to store on the state machine node for debugging purposes. That way, when you use the debugger, you will be able to see the state name instantly, because the state here is going to be an object and it won't be easy to see which state you are currently running in the debugger. So to update the state name, we're going to use a setter function along with our state. So use the setGet keyword and call it set state here. And I'm going to create it at the bottom of the script here. Create a function called setState. It's going to take the new state, assign it to the state variable, and it's also going to assign state.name to our state name variable here. Then come the callbacks. Just like in our state we had unhandled input, process, etc., we're going to have similar things, a similar setup in our state machine. Unhandled input. This time around, we're going to delegate that callback to the currently active state. So whenever we receive an input from Godot, we're going to call state.unhandled input and pass the event along. And the setup is going to be similar for the process function. We're going to call state.process, passing the delta value along, and for physics process, state.physics process, and pass the delta value. The point of that, again, is that the state machine will only have one active state at a time, so it will delegate these callbacks to a single state amongst all our state graph. Then we are going to create a function to transition between states. Let's call it transition2, and it's going to take a few things. A target state path relative to the state machine, it's going to be a string, and it's going to take our message dictionary here, not return anything. It's just going to change the active state. Going back to the scene tree, that target state path is going to be the path to the node that we want to get. So move for move, but for the run state, it's going to be move/run. All right, so we want to do a few things. First, defensive code. If that target node does not exist, we return from the function, we don't transition, and we don't get any errors. So if not hasNode, again, hasNode is a function from the node class. We're going to use the target state path. We're going to just return from the function. Then, if we have that node, we can get it. So target state is going to be the node that we get from our target state path. So we get the new state, the target state we want to transition to. Then we're going to exit the current state. So state.exit. Then we're going to change the state that is currently active. So it's going to become target state. It's going to go through our setState function and update the state name. The self dot is necessary for the setter to be called when doing that change from within the state machine class. And then we're going to enter the new state. State.enter, and we're going to give it the message that the state class has, right, in its enter function. Finally, we're going to add a signal for our state machine that we will use to update some user interface or different parts of our game object systems. We're going to create a new signal called transitioned here. So at the top of the script, create a new signal called transition, and then it's up to you to choose the type of information you want to pass in. We've chosen to give the state path, so the node path relative to the state machine, because we mostly use it to get the name of the current state or those kinds of things. Another option is to pass the state, right, directly, but we're gonna go with state path. Now going back down to our transition to function, we're going to emit that signal. So it's going to be transitioned, and we want to pass the target state path. And this function, now, the point is that from our states, we will be able to call it. So we can do then at some point in one of the function callbacks, state machine dot transition to, and pass the path to a given state. So for example, move/run. And we'll use that in a moment to test our state machine. But for now, we have one last thing to do. Remember that in our state.gd script, in the getStateMachine function, we are requesting a node that's in the state machine group. We have to add our state machine to that group. To do so, go back to statemachine.gd, and at the top, we're going to add that node to the state machine group in the init callback. Init is the function that's gonna get called on that node when it's instance, when it's created in memory. It's a constructor, if you want, for the node. And so at this point, you can call add to group, and you will add the object to the group state machine. We have one last thing to do. It's to get our state machine started. This involves entering the initial state that we get at the start of the game. So let's create our ready function here. And before we get the state machine started, we're going to wait for the owner to be ready. So we'll wait for the entire scene, for example, a character that has a state machine, we will wait for the character to be ready, because a state machine and the states are typically classes that are going to take control of the topmost node. In our case, the owner of a given scene. And once the owner is ready, we can call state.enter and get the state machine started. Now we have the base code for our state machine, and as every time you have a new system, you want to test it. We'll do that in the next video.